Hi, grade 11s. Today we're going to look at the worked examples in your textbook on page 144 and 145. And this is based on the practical examples that we've been looking at so far this week in terms of packaging. Right, so you'll see there on page 144 that Sean would like to become a bulk wholesaler and is investigating the package arrangement of one of his products. Moy's Instant Chocolate Mousse. And the mousse is packaged in a box with the following measurements. So it has the dimensions of 2 centimeters by 9 centimeters by 7 centimeters. And the standard size of the shipping box is 0.3 meters by 0.2 meters by 0.4 meters. So the question is, determine practically how many chocolate mousse boxes can fit into the standard size shipping box if he packs them horizontally. So he will be packing the boxes along their length in here. So you'll see, if you remember on the previous slide, that the length of the chocolate mousse box is 9 centimeters. And we're going to pack this along the length of the shipping box as well. So how many chocolate mousse containers or boxes can we fit in the shipping box? Just remember that the units you work with needs to be the same. Make sure that your meters are converted to centimeters so that we can make accurate calculations here. So how many lengths or how many boxes that are 9 centimeters in length can fit along the length of the 30 centimeter long shipping box? And that we get by dividing 30 centimeters by 9 centimeters, and it gives us 3.33 boxes. However, we have to round down again, like we spoke about before. The shipping box is too small to fit another mousse box in it, so we need to round down. Now, how many of these mousse boxes can we fit along the breadth of the shipping box? And again, just make sure that the units are the same, so we convert meters to centimeters. We do this by multiplying with 100. Remember, that's the conversion factor because there's 100 centimeters in a meter. So how many can we fit in here? So it's 20 centimeters divided by 2, and we can fit exactly 10 boxes along the breadth of that box over there. And finally, how many of these boxes can we fit along the height of the shipping box? Again, they gave you the measurements in meters. Just convert that to 40 centimeters. So how many boxes can we stack on top of each other along the height of this shipping box? Again, we divide with the dimension of the shipping box, or sorry, the other way around. We take the dimension of the shipping box, which is 40 centimeters, and we divide it by the height or the dimensions given on the product that is packaged inside the shipping box. That's also what I mentioned on the first video when we did this. We are going to always divide by the dimensions on the product that we are packaging. So it's always the dimension of the packaging divided by the dimension of the product we are putting into it. All right. So this answer gives us 5.7 boxes. We have to round down. If we were to put 6 boxes on top of each other in the shipping box, it would stick out of the top of the box and we wouldn't even be able to close it. So we have to round down. So finally, the total number of moist chocolate mousse boxes to fit inside the standard shipping box is equal to the number of boxes across the length times the number of boxes across the width or breadth times the number of boxes in height. So that gives us 3 times 10 times 5, and we are able to fit 150 of these moose boxes inside this standard shipping box. Now the next question is, determine mathematically how many chocolate mousse boxes can fit into the standard size shipping box. And this is a fairly quick calculation. Remember what we spoke about yesterday. All we need is the volume of the box, or in this case, the shipping box, and the volume of the mousse box. So in the first calculation, you'll see there, because it's a rectangular prism, we just multiply length times breadth times height, and the answer is 126 cubic centimeters. And the volume of the shipping box, remember we have to just use the dimensions in centimeters, right? So we take 30 times 20 times 40, and that gives us 24,000 cubic centimeters. Now, how many of the boxes can we fit into the shipping box? And we get that by dividing the volume of the packaging, in this case the shipping box, and we divide that by the volume of the product, and in this case is the mousse box, and you'll see we can fit 190,48 boxes into this shipping box, and they've rounded it down to 190 boxes to the nearest whole number. So why is there a discrepancy or difference between the answer that we got in question 1, which was 150 boxes with the practical method, and the answer in question 2, which was 190 boxes that we got according to the mathematical method? Right, so remember with the practical method, we saw that there are spaces, little extra spaces along the length and height of the shipping box, because when we divided the dimensions of the shipping box with the dimension of the product, there was a decimal, and we had to round down, and that means that where there was a gap, there was a little space left. And if we compare that to the mathematical method, where we just use the volume, it doesn't take into account the shape of the product that we put inside the packaging. It doesn't take into account that we cannot cut in half or squeeze little pieces of the mousse box into the gaps, and therefore we got a much greater answer with the mathematical method. So again, as I said before, be very careful when using the mathematical method. Rather stick to the practical method when they ask you a question of how much of this can fit into that, right? Rather stick to the practical method, and you shouldn't go wrong. The mathematical method is something that we can use when we are working with liquids or products or shapes that will be able to fit and be able to be squeezed in, or fill up all the gaps in the packaging. Right, but stick to the practical method, and also the context of the question. If the question says, if it specifies the mathematical method or the practical method, we just need to always look at what the question is asking and what it wants from us, and also the context. You'll see when you move on to the test your understanding here on page 145 that they ask you how many pizzas we can fit into I think it's a heat insulated bag. And typically when pizzas get delivered, they're not gonna put the pizza upside down into the box or on its side or horizontally. They're gonna put it flat facing down so that you can still get your pizza in the same shape as they made it when they deliver it. So it's also important to take into account the context. Right, so I'll leave you now to continue with the exercise, test your understanding on page 145 and 146. And I believe that is all for today. And yes, I hope you all have a good rest of your week, and we'll see you soon. All right, thanks, grade 11.